So this section is going to be going through the basic properties of exponents that you come across. Some of these things you don't really have to memorize because you can figure them out. The first one we already learned. I mean, that's the one, if you have to make sure that you know the definition of a log. I'm just going to give you a couple of examples on some of these to have you write down. So this one, for instance, if you had something like say log base 7 of x equals 10, well, that's the same as saying 7 to the x, or whoops, doing that backwards. Okay, 7 to the 10th. Okay, if you write that in exponential form, that would be 7 to the 10th is equal to x, like that. Right? So that's what we were working on in the last section, is just learning how to rearrange those forms. That's not new to you. Okay, this next one is just saying anytime you have a log of any base of 1, it's going to be 0. So as an example, if you had something like log base 5 of 1, that's equal to 0. Well, the reason why is real simple. I mean, it's just basically, if you wrote this in exponential form, you would have b to the 0 is equal to 1, which we know is true. So anytime you do a log of 1, you get 0. You don't have to memorize that. You figure it out as it shows up. So, for example, if you had log base 11 of 1, your thought process is, what power of 11 is 1? Well, that's 0, isn't it? Okay, so you figure it out as you need to. You don't have to memorize that if you don't want to. Okay, the next one's kind of the same way. You can memorize it, or you can figure it out as you get to it. Okay, so is what you can do. So an example on this one would be something like if you had, say, log base 4 of 4 to the 10th power. Okay, now the key thing on this property is saying that those two numbers have to be the same. Then it turns out the answer is just 10. Okay, so if this ever showed up, here's how you could figure this out. So for instance, let's say that you had something like log base 3 of 3 to the 5th power. If instead of memorizing this property, you could just figure it out. Okay, you could set that equal to x and write this in exponential form. So if you did that, you would have 3 to the x equals 3 to the 5th. Well, what does x have to be? It has to be 5. It can't be anything else. Okay, so x is equal to 5. All right, so that's something that you can memorize, or you can just figure it out as you come across it. Okay, that's the idea. Okay, all right. This next one is one that you probably want to memorize. This one, I'm going to show you where this comes from, though. So the idea with this one would be b is a base. So I'm just going to pick a number like, say, 8, and if the exponent is a log of the same base, and say that's like 10, then it turns out the answer is 10. This thing right here, when I teach Calc 2, shows up all the time, very, very commonly, not so much in Calc 1, but things we do in Calc 2, that property shows up quite a bit. Let me show you where this comes from and see if this makes sense to you. This is kind of like how you derive this formula. And you should write this down because it's useful to know where this one comes from. So what I'm going to have you do is just write down log base b of x equals log base b of x. That's obviously true because it's the same thing. Well, look what happens if you write this in exponential form. If you take this whole equation and write it in exponential form, you would have this to that power equals x. That ends up being the whole exponent right there. So you would have b to that power equals x. That's where how this formula gets derived. So that we'll just write down the base. This whole thing becomes the exponent. And then that's equal to x. Does that make sense? Sometimes students have a hard time seeing that one for some reason. Well, that's where it comes from. It's just the idea that if you have two logs that are exactly equal, you write it in exponential form, and that's where that property pops out. Okay, it's out of that. So this one is a real simple one to see. So anytime you see any number, it doesn't matter what it is, if you had 100 log base 100 of 5, the answer is 5. But the key thing is those things have to match up. If those bases are different, then it doesn't work anymore. So that's the idea. So it's very simple once you learn that, okay, and spot that when it shows up. Okay, the next ones are, I'm not going to do like a derivation of this or anything. I'll probably just demonstrate maybe something on the calculator on this. So just as an example, let's use like base 10. So like if you had log of 5 times 7, that turns out that that's the same as the log of 5 plus the log of 7. So if you have a product, the basic idea is if you had a product, the product can become the sum of two logs like that. Okay, and I'm not going to derive that one or anything or do like a derivation of that. I'll just demonstrate this on the calculator. That's probably good enough for our purposes. So if I did the problem that I just made up, log of 5 times 7, you get logarithms if they're not whole numbers. They're just irrational numbers with decimals. Well, if I did log of 5 and then plus log of 7, then I get exactly the same answer. Okay, so you can change a product into a sum. That's what that says. Okay, and then the next one is a quotient. So it turns out that if you have a quotient, you're just dividing, you can change that into a difference of the two logs. Okay, like that. All right, and again, I'll just do a demonstration. This time I'll do ln. So let's say you had ln of 10 over 7. Okay, that would be the same as the ln of 10 minus the ln of 7. Okay, so it'd work exactly the same way. If I do ln of 10 over 7, I'll get decimals that repeat infinitely. But if I did ln 10 and then subtracted ln 7, I should get exactly the same answer. That doesn't prove anything, it just demonstrates it. Okay, so that's the idea. You'll be using those properties quite a bit when you solve equations of certain types that are a little bit more complex. Okay, so you want to, as you're working these things out, you want to get these properties down, as many as you can. And there's two other ones I'm going to look at on the next page. And this one basically just says this: if you have a logarithm of a number to a power, then the power can come down in front of the log. So for instance, if you had something like log, I'm just going to put base 10. So let's say we had log base 10 of 8 to the 3rd power. Okay, well, it turns out that's the same as doing this 3 times log base 10 of 8, or log base 10 of, whoops, I put the wrong thing there, of 8. So you can bring that exponent down in front. You use this property a lot when you're solving exponential equations, okay? This is an easy one to demonstrate on a calculator also. If you just do, I'm going to just do the log. So if I did the log of 8 to the 3rd, yep, that's not what I meant to do. So I get that, and then if I just do 3 times the log of 8, then I'm going to get exactly the same thing, okay? So that's one that you're going to use quite a bit. This one is just basically saying this. It says that you can take a log of both sides of an equation, okay? That's something that you're kind of familiar with anyway. Is you're used to doing the same operation to both sides of an equation. Well, you can do a log of both sides of an equation, or you can remove the logs of both sides. So it's really just saying if you had something like x equals, I don't know, something like y plus 10, and it's okay to do a logarithm of any base of both sides, okay, or remove those from both sides. That's what that property is basically saying. All right, so what we'll do is in practice, we're going to go through and just work some illustrations of some of these properties out. And some of these things will refer to whatever property we have. Okay, so there's a property on this one that said anytime you do a log of 1, you just get 0. So this is like the second property. By property 2, you just get 0, okay? Anytime you do a log of 1, you get 0. You don't have to memorize that one because, again, the meaning of this problem is log base e of 1. If you needed to figure it out, you would just do like we've been doing today. Just e to what power is equal to 1, that's 0, okay? All right. The next one, I think, is you don't need to know the property on this. You could just set that equal to x and figure it out. So this would be saying 3 to the x equals 3. So what does x have to be? 1, okay? So the answer to that one is just going to be 1, okay? There's a property that says the log of a number to the same base is always 1, but you can figure it out, okay? This one's kind of the same way. This one you can figure it out instead of remembering the property. The property on the previous page just said that answer's 3, okay, when you have that situation. But if you encounter this, just do this, okay? Just always do this same process to figure most of these out. That would be 9 to the x equals 9 to the third. Well, x would have to be equal to 3, see? Okay, so you can figure that out. The first 3 problems that I've done on there, if you don't remember the property, like I said, you just figure it out. Okay, how about the next one? Do you know what the answer to the next one is? We did that a few minutes ago. It's staring you right in the face. This is one you'll do in Calc 2 all the time. The answer to that one's 10. Okay, just make sure that those bases match up. Okay, if you look on the previous page, that was property number 4. Okay, and then the next 2, you got to do the this number E. This is the, I think, property 5 and 6. Okay, so this is these are both property 5. These last 2 right here. Okay, so what you do with this is if you have a sum of logs, what you do is you write this as 1 log and then you do the product. Okay, property 5 says that if you have a sum of 2 logs, it can be compacted into 1 log of the product. So this would end up being log base 6 of 36. Now you can do this in your head. You would want to be able to tell me what the answer to this is in your head. What do you raise 6 to get 36? 2. So the answer is 2. You can do that in your head. Okay, any time that you can take it to the very end, you want to do that. 6 to the second is 36. Okay, and then this one would be property 5 also. You have a product, so you would write this as log base 3 of 9 plus a second log base 3 of 27, like that. Okay, and then again, you want to do this in your head like fast. Okay, what would this be? 3 to what power is 9? 2. How about this one? 3 to what power is 27? 3. Okay, remember, when you're doing a log, the answer is an exponent. Okay, so that one's just going to be 2. That one's going to be 3, so the answer to that problem is 5. Okay, and by using that property, it's real easy to do that way. Okay, you don't have to multiply out the 9 times 27. You can break it up into a sum, and it's a lot easier to do it that way and consider it. Okay, any questions so far? Okay, just kind of depends on your background. A lot of times students are kind of shaky with logarithms. Try to understand that it's an exponent, okay, and that'll help you. That's really what we're looking at, is an answer to a log is an exponent. Okay, let's do 2 others. And this one, first of all, on this one, we want to think about what you could do to that exponent, okay? The property 5 that we just looked at said that if you have 2 logs added, how do you put it into 1 log? 1 log multiply, right? Okay, so you could write this as 5 raised to the log base 5 of 6 times 7. Okay, so that would have to be put together like that. Now that would be 5 raised to the log base 5 of 42. Okay, what's the answer? 42. Okay, that's that property that we said anytime you have b raised to the log base b of x, the answer is whatever that number is. Okay, so that's 42 by the property we learned. But again, make sure those bases are the same. If they aren't, it's not going to be 42. Okay, so that's how that one goes. Okay. All right. This one, the answer on this will turn out to be square root of 3, because the property that we looked at was if you had log base b of b to the x, the answer is just x. Okay. Again, if you don't remember this property, this is what you would do anyway. You would just say, okay, ln is log base e to the square root of 3, just set it equal to x, and then this is all you got to do to figure it out, is just write this as e to the x equals e to the square root of 3. Therefore, and this is this thing we see all the time, if the bases are the same, which they are, then so are the exponents. So therefore, you would end up figuring out that x is square root of 3. Okay? But if you know the property, you can just, boom, boom, you can do that in a hurry. Okay? So that's kind of the idea. When you're working out problems like this, they are exercises to get you comfortable with the different properties. You use them in different situations, mostly when you're solving equations and simplifying expressions. Okay? The next thing I want to show you is the change of base formula. This is actually real helpful in Calc 1 when you learn about how to do derivatives of logarithms to different bases. If you understand how the change of base formula is, it kind of saves you from having to learn another rule in calculus. So it basically just goes like this. Your calculator, now most of the modern calculators will do all bases, and I'll show you how that works in just a minute. But the only keys that show up are the base 10 and the base e key for log and ln. So the change of base formula, you can do this if you want to. So if you're working out log base 5 of 20, the change of base formula says you just do the log of the argument 20 and then you divide by the log of 5, or you could use the natural logarithm. You could do a natural logarithm of 20 over natural log of 5 like that. And then you can do it on your calculator that way. So if your base is anything other than e or 10, you can use the change of base formula. So I'm just going to do log on this. I just do log 20 and then divide by log 5. And then I'll get a bunch of decimals. I'll just round this off. So let's just round it to like maybe 4 decimals or something like that. So 861.4 if you rounded that off. Okay, so that's how the change of base formula works. Real easy to remember that. This one, again, you can do log or ln. It doesn't matter. I'm just going to do ln. So we'd do ln of square root of 2 all over ln of pi. You probably would want to use your pi key on this. So I'm going to go ln square root of 2 and then divide by ln of pi. I'll just use the pi key on this again. And then round that off, so that would be about 0.302, and I'll just round that to 4 decimals like that. So that's how you can do that. Now let me see if I remember where this is on your calculator. If you have a 84, I think if you go to the math button, I can't remember where this is because I never use it. It might be on the number thing. There's that log thing somewhere. It may just be under math towards the bottom. There it is, right there. Okay, so, and you can write this down if you want to. If you do the math button, and then you do option A, log base. I just never use this because the change of base formula is so easy to use, and I always forget where this is. So it looks like what you can do is go there, and then you could put in, and it sets it up for you. So like this problem number 1, you have the base 5, and then you have the 20 there. So it'll do all these things for you. So it gives the same answer, okay? So that's up to you how you do that. But I do want you to know change of base formula because it's very, very important, I think, in Calc 1 when you're dealing with logarithms, okay? All right, let's see. This next one, what I want to do on this is just use a couple of properties. Now, this one you could put in your calculator, but I didn't design the problem that way. We're going to use the change of base formula on this. So the first one, what we would do is write this as ln of 8 all over ln of 3. And then the second one would be ln of 9 over ln of 8. Well, notice what happens on this is ln of 8 is a number, so that would divide out. Then you would end up having the ln of 9 over the ln of 3 like that, okay? So then what you can do with that is, this is really the same thing. You could go through, and if you look at kind of back at the properties you have on this, you could go through and you could either just use your calculator on this, but I wanted to kind of show you how this goes. So if you put this in your calculator and did this now, you'll get a whole number on this. So if you did ln of 9 and then divided that by ln of 3, then you just get 2. Okay, and that has to do with the way the exponents are on that then. So what you would end up having with that is you could work that out then on the calculator, or you could write it like this. This is really what happens on this problem, is ln of 9 could be written as ln of 3 to the second. This is why the calculator gives you a 2. Okay, then we have a property that says that 2 comes down in front to leave 2 times ln 3 over ln 3, so that's how you get a 2 out of that. Okay, calculator would certainly figure that out for you, but you can do that whole problem by hand by doing that. And it's just the fact that the 9 is a power of 3, that's why it worked out the way it did. Okay, all right, any question about change of base formula? There's nothing to it. Okay, I'm not going to really show you where that comes from necessarily, but that's something that's pretty useful to use, and then you can use your calculator on different bases also. The next thing I want to show you is this is just getting comfortable with the different properties we have. So on the next page, we're going to use these properties 5, 6, and 7 on here quite a bit. And this is a skill that you do a lot when you're solving equations. All right, so what we do with this one is we're going to write each expression just as a sum or difference of logs. So this one would be an illustration of property 6. Okay, and some of these start off real simple and some of them get a little bit more advanced. So this one you would just write this as log base 4 of the numerator minus log base 4 of 8. Now we're not going to really work any part of this out. We're just going to use these properties 5, 6, and 7 as we need to. So that's all you would do with that, is just break that up like that. Okay. The next one would be property 5 that says if you do a log of a product, it's the same as breaking it up into the sum of the two logs. So this one would have a couple of steps on it actually. The first thing you could do is say ln of e to the negative x plus ln of y. That's what property 5 tells you can do. Now property 7 tells you that if you have an exponent, that can come down in front of the log. So that's what this property is telling you to do. So that would be negative x ln e plus ln y like that. And there is one other thing you can do with this problem. You can figure out what ln of e is. You don't have to memorize that. ln of e means the same thing as log base e of e. So it's equal to 1 because e to the first is equal to e. Okay, so that would just end up being negative x plus ln y because ln of e is equal to 1. Okay, all right, so that's how that one would get broken up then. The next one is also property 5. Again, you have a log of a product of two expressions, so you break it up into a sum. So this one you would say ln of x plus ln of square root of 1 plus x squared. And then you want to take this a little bit further. So what you want to do with this is you want to write that square root as a 1/2 power. You don't want to stop at this point. You want to write that as ln 1 plus x to the second to the 1/2 power. Rewrite the square root that way. Now, what could you do with the 1/2 according to property 7? You just bring it down in front, right? Okay, so property 7 would tell you to bring that down in front. So you would have ln of x plus 1/2 ln of 1 plus x to the second, like that. And then that would be as far as you'd want to take that then. Okay, just break that up as far as you possibly can. All right. Okay, let's do this number 7 here. And this one, the first thing you got to do, you got to start at a certain point. Now, the fact that it's a quotient means you're going to use property 6. But what could you do with the 3? Anytime you have a log of something to a power, what can you do with the power? You can bring it down in front. So the first thing to do, and you have to start this way, would be to bring the 3 down in front. So you would have 3 log base 2 of 2x minus 3, okay, all over x plus 1, like that, okay? So what we'll do now is we do property 6, which just says we'll bring down the 3. Now you'd have to create a grouping symbol there, and then you would have to say log base 2 of the numerator, and then according to property 6, you just break that up into a difference. Then you'd have log base 2 of x plus 1, like that, okay? And then that would be as far as you would want to take that then, okay? So these are exercises primarily that get you used to using the different properties of logs. This whole section is all about these main properties, okay? Let's finish up with just maybe, we'll see how many of these we can do down here. So this one, if we don't finish, that's fine. So this one, we're going to do this backwards. We're going to write as a single log. So what you'd have to do is you would have to start, anytime you have a number in front of a log, that comes back and becomes the exponent. So that's using that property number 7 in reverse. So you would start by saying log base a of x to the second plus, and then the second one would be log base a of y to the 1/4, like that, okay? Then you can write this as a product of the two. So since it's a sum, you just write this as log base a of x squared y to the 1/4. So you're doing in reverse what we did on the last problems, basically. That's the idea, okay? All right? And then this next one here, again, bring the 2 in front. So you'd have log x squared plus 3x plus 2 minus log x plus 1 to the second. Okay, now this one, since it's a difference, you would put it together in a fraction. So this would go like this. You would say log x squared plus 3x plus 2 over x plus 1 to the second, like that. Now I think you could factor that, and maybe one of them cancels out. So that numerator factors as x plus 2, x plus 1. So then you could remove one of those factors out of that. So you would end up getting just log of x plus 2 over x plus 1, like that. Okay, and that would be the idea there. So again, you're doing that in reverse. Let's go ahead and just got one more problem to do. Let's go ahead and finish that up on the next page, and that'll get us through this whole section. It's a pretty short section. You're mostly just learning the properties. So this one, what you're going to do is bring up the exponents. So you would have as your first step log x to the third plus 1 to the 1/3 plus log of x squared plus 1 to the 1/2 power. And then if you have a sum, you write it as a product. So that's because that's a sum. You would just write this as log x to the third plus 1 to the 1/3 times x squared plus 1 to the 1/2. And you don't have to change those to square roots or anything. That would be an appropriate answer to that problem. Okay, so the last couple of things I'm showing you on there is just how to use those last properties to expand logs or put them together. That's the idea. All right, so that'll wrap us up on that. And Then next time I'll give you the next two handouts on logs to finish up chapter 4.